Data types and variables. Part 2. Here are the contents. Scope and extent of a variable. Type checking methods. An overview of typing. What is a data type? Early data types. Present data types. Advantage of data types and conclusion. Scope of a variable describes where in a programming text the variable may be used, while the extent describes when in program's execution a variable has a value. The scope of a variable is actually property of the name of the variable, and the extent is a property of the variable itself. Most languages define a specific scope for each variable. This may differ within the given program. Extent, on the other hand, is runtime aspect of a variable. Each binding of variable to a value can have its own extents at runtime. The extent of the binding is a portion of the program's execution time during which the variable continues to refer to the same value or memory location. Running program may enter a leap given extent many times, as in the case of a closure. In portions of code, a variable in scope may never have been given value, or its value may have been destroyed. Such variables are described as out of extent or unbound. In many languages, it is an error to try to use the value of the variable when it is out of extent. In other languages, doing so many is unpredictable. Type checking methods. First one is static typing. Static typing means that type checking is performed during compile time as opposed to runtime. Static typing is a limited form of program modification. It allows many type errors to be caught early in the development cycle. Static type checkers evaluate only the type information that can be determined at compile time. Program execution may also be faster or taking reduced memory by omitting runtime checks and enable other optimization. Some of the most commonly statically type checked languages include C, C++, C#, Fortran, Java, and etc. The other method is dynamic typing. A programming language is said to be dynamically typed, and majority of its type checking is performed at runtime as opposed to at compile time. In dynamic typing, values have types, but variables do not. That is, variable can refer to a value of any type. Compared to static typing, the dynamic typing can be more flexible. Dynamic typing may result in runtime type errors, which at runtime a value may have an unexpected type, as if place whether wrong type of data passed into a place it should not have. This may make it difficult. Development in dynamically typed languages is often supported by programming practices such as unit testing. This method can detect a much wider range of errors than static type checking. Dynamically typed languages include JavaScript, Perl, PHP, Prolog, and etc. Let's take an overview of both statically and dynamically typed languages. First one is static typing. The following diagram represents is description of one of the ways these terms are most commonly used. In statically typed language, every variable name is bound both to a type and to an object. The binding to an object is optional. If name is not bound to an object, the name is to be null. Once a variable name has been bound to a type or declared, it can be bound only to objects of that type. It cannot ever be bound to an object of a different type. An attempt to bind the name to object of the wrong type will raise a type exception. In a dynamically typed language, every variable name is bound to an object unless it is null. Names are bound to objects at execution time by means of assignment statement, and it is possible to bind a name to objects of different type during the execution of the program.